Thank you. Yeah, so a few months ago, I found myself in a situation of having to build and maintain a lot of websites. Websites such as this one. This is activegroup.de, which is the company I work for. This is the company's website. There's some standard information on there about the company. For example, we do trainings in functional software architecture, and the trainings, they have training events and trainers and so on. Or I built this website, which is functionalarchitecture.org, which is just an information website about what is functional architecture. We don't discuss this now, but if you're interested, I will talk to you afterwards. Or this one is just a standard blog. Funktionaleprogrammierung.de is a German blog about functional programming, basically. Or we have a conference website, so we do a little functional programming conference, usually during February and March in Berlin every year, called BobConf, and this is the website, so it has to talk about speakers and talks and schedules and so on. So quite different websites, but they all have one thing in common, in that they're all static websites. And you can tell that they're static websites because they're created by a static site generator. Something like Jekyll, if you maybe heard of that. For example, if you make a new GitHub Pages project, I think the default is that you have a Jekyll tool running there, generating your site, your static website. So what is a static website? Well, we're not talking about no JavaScript, right? So we can have JavaScript on a static website in this, with this notion. What I mean by static website is something like this. So usually one representation is you have a list of files inside folders, HTML files, JavaScript files, and so on. For example, here we have a bar and a foo directory. They each have an index HTML with some content in them. And now if we run something like an Apache on this directory, or something like whatever GitHub Pages uses, then we can curl the website that is then running, for example, for the foo path, and it gives us back hello world, or we can query it for, or we can curl it for the bar path, and it gives us bye-bye. And now the important thing is that whatever we do, it's always giving back the same answer. So no side effects here, and no state. So this sure looks like a pure function to me. So I built these websites, I maintained them, I built some new features for them, and I had to use Jekyll, and I was, after a while, a bit dissatisfied with the tools that Jekyll provided me. So I looked around at other static site generators, and they all had the same problems, basically. So I set out to write my own static site generator. And the requirements for that project, some of the requirements are up here. So I wanted to have proper tools for abstraction, something like lambdas, right? So we are functional programmers. Our one tool for abstraction is the Lambda, and all of these static site generators, like Jekyll, well, they have some kind of abstraction mechanisms at some level, but overall, like in the end, they all deal with files and folders still, and it's harder to implement a Lambda in terms of a folder. Also, I want to have algebraic composition, so I want to build larger websites from smaller websites, and again compose them to form ever larger websites. And maybe the most subtle point is the third one: separation of concerns between all kinds of concerns, but especially I want to separate the domain model of my website from the presentation. So you might think, oh, these static websites, they're all about presentation, which in some sense is true, but still I want to keep the domain model isolated as far as possible, and I want to have my little domain business logic there, and then at some later point I can have a presentation or many representations in some cases. And the last point I'll get back to in the end. So I set out to fulfill these requirements, and I chose OCaml. The abstract says so. This talk is not going to be much about OCaml. I have to disappoint you. It's much more about the underlying ideas, which you can just replicate in any language. But here's a little impression. So this is the domain model, or part of the domain model, for the active group website where we have trainings. So there's a record for trainer, for example, and then Schulung, that is a German word for training, references a list of trainers. And then we also have training events, Schulungstermin, and that has a start date, end date, location, and so on. So this is just normal like domain modeling, nothing special so far. But already you see I use a proper programming language, no DSL, just use the programming languages that are already out there, tried and tested. And that gets you very far just by starting there. And now I wrote a little library that now lets me now allows me to write very short descriptions of websites. So for example, here I write a little function short of trainer. So trainer is now the thing that we saw before. And for every trainer, I describe a website. So this is looking a lot like HTML only, but if you look closely, you have something like this let and, where we build an image. So already this is building 2 pages, right? So this is not just one page with HTML. This is building a page where the image data lives, and then another page where we display the image with some other stuff around it. So for this talk, I want to go a few steps back. So forget about this OCaml stuff for now. We want to derive this idea from first principles, basically. And then we have to ask ourselves again, what is a static website, or what is the essence of a static website? So already we saw one representation, which is this set of HTML, CSS, and JS files in folders, but that's just one representation. For example, as a user in the web browser, you don't see any files, you just see HTTP requests and response tuples, right? So the underlying idea behind those 2 representations, of course, I think, is a pure function. So we start by doing that. We say website. And immediately we, like the talk title is from URL to HTML, but doesn't hurt to abstract in both of these arguments, right? So we say a website from A to B, where A and B are abstract. It's just a function from A to B. And now we can build some useful website combinators, such as this const here, which takes B and then gives you a website of A to maybe B, and the definition is just whatever goes into this function, it just returns just X always. Another useful combinator is map, of course, where we map a function B to C over website A to B. Out comes a website A to C, that is just function composition. And map2 is basically the same thing as lift A2 in Haskell. At some point we have to talk about like a more concrete input type, and we'll do that by saying we have URL paths. A path is just a list of strings, so at this point we already made segments out of a path where the slashes have been, we passed a list out of this one string. And then for some more useful primitives and combinators, we have an empty website, always displays nothing. And we have this OR combinator, which takes 2 websites, A to maybe B, and then tries the first one with a given URL. And if that returns anything other than nothing, that's the answer. If it returns nothing, we try for the second website. And then there's this seg combinator, which takes a string and a website, and then returns a website that, when given an empty path, here it returns nothing. And if it returns a path with at least one segment, we compare that segment in the current URL, the first one, with the segment that we have given to the combinator. If they're the same, then we continue with a website W that's also inside the combinator with the rest of the URL. Else it's nothing. And with these few simple tools, we can already build some websites that are quite useful. For example, these ones, right? So x1 and x2 are just constantly displaying some string, hello world and bye-bye. And x3 now wraps each of these with a seg, right? So we have seg foo x1 and we have seg bar x2, and we OR those together. Right? So, and this is now a website with two distinct paths. Right? Gives you nothing for everything that's neither foo nor bar, and gives you the corresponding text when you present it with foo or bar. I'm going to skip this, and then I'll have to ask now: is this it? Like, is this just the entire talk? Static websites are pure functions? Well, yes. Kind of the answer is yes, but still we want to have this representation with the files and folders. That is quite useful to have because remember we can use a standard Apache web server and they understand this format, or use GitHub Pages or something like that. So it's still a useful representation to have, and so we want to have that representation as well. But total functions, what we just saw, total functions, they're too powerful. They have a too high of a fidelity, you could say. Right? Because even just looking at this const thing here, that means that for every URL that we present to this website, we get hello world back. So that already is an infinite number of files that you had to render. This is certainly not practical. But I think the right idea to deal with this problem is that we use these high fidelity website functions to combine and to compose, right? This is the powerful stuff that we as programmers want. And then in the end, yeah, we want to render a set of static files, but we do that by sampling these functions. And in order to sample, we need some idea of a sample, which is just a key value map. And then sample is just a function, takes a function and a list of URL or paths in this case, and then returns such a path map. Quite straightforward. So are we done now? Is that it? Well, kind of, yes. But where do these URLs come from? Now the user has to provide them, right? But we saw in the example, we mentioned bar and foo already. So the website that we build up, well, it could suggest some good sampling points itself. So that's one improvement that we can do. But in order to do that, we have to reflect our functions that we build into a data type. So that's what this is. Don't have to read that. And this is just a function that retrieves the original function back out of this data type. And now that we have reflected our functions as data, we can write something like this. Sug is for suggestions. And for suggestions, well, for the const function, don't really know what to suggest here. We just suggest the empty path, so the empty, like no path here. For map2, for example, we just recursively descend. This has just given up on me. We recursively descend. Also for or, right? We just concatenate the two suggestion sets. And then the seg is the interesting part where we take the suggestions from the inner website and then prepend on every element the S, which is explicitly given to this combinator. And this works. So here we have a little, now we can build a render function, which is sampling our website, so our function, at its own suggested rendering sampling points. And if we do that, then we get out something like this. So x3 prime t, it's somewhere up here, and the output is this, right? So, and this is just a map. Associates foo with hello world and bar with bye bye. And now to render that as files is just one little layer more. I think I'm quite good in time. Yeah. So are we done now? Again, I have to ask this question again and again. Yes, but we forgot one important requirement that I skipped over in the beginning, which is that is a website really just a pure function? Remember, websites, they have these links, right? And you click a link and you go to some other page, and we still refer, if it's an internal link, to that other page as part of the same website. And ideally, my language or my DSL supports this construction of links in a manner that is correct by construction. So I don't want any broken links, right? And my OCaml library has a tool for that, but I don't know how to formalize that. I just came up with something, and you see that here in the let end, that says image ref is something, and then our image ref is a token that you can that is a token attached to another page or another website. And I can deref it down here where I say that the image has a source of deref image ref. So I have built some tool to deal with that, and it works, but I don't really know what it does. Because it's a bit of a, like these two requirements are a bit of a contradiction, I think, right? One requirement is that I want to compose websites to form ever bigger websites, and I don't want to think in terms of pages at all, because pages is an artifact that comes at the end. But now links, I think, they mention pages. So if I want to build a website, like a small part of a website that mentions another page, I have to somehow bridge these two worlds, which I'm not sure how it does that. So this works so intuitively, it always does the right thing, but I don't know what it does. And that's an open question, how to formalize that, basically. Yeah, so that's a progress report on this little project. And if you want to help, you can either talk to me after. There's maybe room for 1 or 2 questions now, or you can write an email to this address.
Yeah, there's time for questions, definitely. We have 3 minutes if somebody wants to ask Markus something. Yes? I'll meet you halfway.
So the question is about your deref system, the one you talked at the end. I was wondering if the problem is, well, you don't know exactly where a thing will end up.
Yes, that's it.
But ideally, it could end up also in the same page, in another page, everywhere.
Yeah.
So this has to manage also link. It is like a reference, the one I put in a LaTeX document, for example.
Yeah.
Okay, so this is actually a good idea, I think, because it allows you to abstract over that concept, and it allows you to use it for linking inside the same page. That this is not something you usually do in a static site generator, because your requirement is actually wider, I think, than what you usually can do in your. So this approach is really flexible. I'm sorry if it's not really a question, but I wanted to make sure I understood it correctly.
Yeah. So maybe what you're kind of referring to is that we can, like, I'm with this deref thing, with this let end. There's actually other stuff. Let end is just an operator on top of another thing, but that creates a token and then attaches that token to a website, right? Which can be a part of a larger website, either as a singular page or as a part of like one small headline, for example, in where there's most of. Yeah, that's exactly right. And yeah, I could also attach an anchor or something like to that, right? And then I could deep link into that page, which I don't do yet, but that's certainly possible. But I still don't know what, like in terms of functions, right? I wanted to, I presented to you this specification here, what it means in terms of this formulation. Right, like a link here is more like an argument to that same function, or to, well, that same function either, or another function's input type. But hand wavy.